Okay, after we learn about the three fundamental theory of capital structure, then we're going to learn about what is the optimal capital structure for the company. So we're going to look at the optimal capital structure in the company. Basically, the theory says that there is an optimal capital structure at which the firm's weighted average cost of capital is minimized, and therefore the intrinsic value or the market value of the firm is maximized or optimized, right? So what do? We use what's called Hamada equation. So Hamada equation basically was adapted from the Modigliani and Miller with corporate tax. So what does the Hamada equation says? Hamada equation basically used beta. If we know that beta is a measure of firm's risk on the stock investment, then why don't we just adjust the beta based upon the after-tax debt-to-equity ratios? So that's basically what Hamada's equation says. So the Hamada equation basically explains that the beta for firm with debt financing is equal to the beta for firms with zero debt multiplied by 1 plus after-tax debt-to-equity ratio. Why is it 1 plus? It's basically like compounding, right? So that beta unlevered multiplied by 1 is basically the risk of the firm without debt, plus that beta unlevered multiplied by the after-tax debt-to-equity ratio, right? So the beta unlevered is basically beta unlevered plus multiplied by 1 plus after-tax debt-to-equity ratio, which this is basically coming from the Modigliani and Miller with corporate tax that we have discussed in the second theory. So if we get the beta levered is equal to the beta unlevered times 1 plus 1 minus tax times debt-to-equity ratio, then the beta unlevered is the inverse of that. Basically is equal to the beta levered divided by 1 plus 1 minus tax multiplied by debt-to-equity ratio. So here's an example, right? Firm X currently have 20% debt and 80% equity. The beta for the stock of firm X with the current capital structure of 20% debt and 80% equity is 1.2. And the cost of debt is 8%. Now this firm is considering of changing its capital structure. And it's going to change its capital structure to 40% debt. So they're going to load on more debt. Instead of 20% debt, now we're going to consider of 40% debt and 60% equity. And the estimated cost of debt will increase from 8% now become 9%, right? More debt, that means more risky. Then the debt holders or the bond investor require higher yield to maturity, right? So higher yield to maturity, that means higher pre-tax cost of debt. And if the risk-free rate is 4%, then the market risk premium is 6%, and the corporate tax is 30%, the question is, should this firm X consider of changing this capital structure from 20% debt to 40% debt, more debt? Is that something that they need to consider? So what do we do for this problem? The first step of this calculation is to look. This beta 1.2 that is given to us in the problem, is that the beta for a levered firm or unlevered firm? Since there is a debt of 20%, this 1.2 should be the beta for levered firm, right? Beta levered basically is beta for firm with debt. So if this is 1.2 is a beta for levered firm, the first step is to calculate the beta for unlevered firm. Firm X, unlevered firm, beta, which is the beta levered divided by 1 plus 1 minus tax times debt to equity ratios. So we divide 1.2 divided by 1 plus 1 minus 30% times 20% over 80%. So we get the beta of the unlevered firm is equal to 1.0213. This is basically the beta for firm X as if firm X has zero debt. This beta unlevered of 1.0213 also represent operating risk because we take out the financial risk, there is no financial leverage, there is zero debt, then that means 1.0213 represents operating risk of the company. If we take out the financial risk, what's left in the risk in the company is operating risk, right? So we discussed the operating risk from the previous lecture. So now we know that the unlevered beta is a measure of operating risk. Step 2 is to calculate the relevered beta. Under the new capital structure of 40% debt and 60% equity, what would be the beta levered? How do we do that? We have to use the beta unlevered from the step 1 and relever it using the new capital structure. So we multiply the beta unlevered 1.0213 with 1 plus 1 minus tax multiplied by 40% debt and 60% equity. That's the new capital structure. So we're going to get the beta relevered with more debt financing at 1.498, which is higher than the initial beta 1.2. We should get the higher beta, right? The higher debt to equity ratio, after-tax debt to equity ratio, the higher after-tax debt to equity ratio, the higher the levered beta should be. So this is natural check that we should get a higher beta relevered if we have more debt financing. And then step 3, we apply CAPM, the capital asset pricing model that we have learned, right? The capital asset pricing model basically says that the required return for the stock investment is equal to the risk-free plus the beta lever for this stock times the market risk premium, or market return minus risk-free. That's market risk premium, right? So we calculated the cost of equity under two capital structure. Under new capital structure, we get the cost of equity is equal to 4%, which is risk-free, plus 1.498, which is the beta relevered, times 6%, which is the market risk premium. We get 12.99%. Under the initial capital structure, which is 20% debt and 80% equity, the cost of equity, or required return cost of equity, I call it RS old here, is equal to 4% plus the beta was 1.2 initially, times 6% is the market risk premium again, is equal to 11.2%. So we calculate, the step 4 was to calculate the weighted average cost of capital under this two new capital structure. Under the new capital structure, we're going to put 40% debt times 9% is the pre-tax cost of debt times 1 minus 30% tax rate plus 60% of equity financing times the required return for the equity financing on this capital structure of 40%, which is 12.99%. So we're going to get the weighted average cost of capital of 10.314%. Under the initial capital structure of 20% debt and 80% equity, we calculated weighted average cost of capital also is 20% debt, or 0.2, times 8% is the pre-tax cost of debt, multiplied by 1 minus tax, right, which is the tax rate is 30%, plus the 80% of equity financing times the cost of equity under 1.2 beta, remember, 11.2%. So we get the weighted average cost of capital of 10.08. Then compare between these two, right? We can see that under the initial capital structure, the WACC is lower, right? If this is lower, then we choose the WACC that is the lowest. That means if the WACC is lower under the initial capital structure, which is 20% debt and 80% equity, then this company should not change into the new capital structure, because by changing into a new capital structure, this company weighted average cost of capital actually increases. Because of this, that means there should be an optimal capital structure of the company, because we are able to adjust the beta based upon the after-tax debt to equity ratio. So that is basically the idea of the optimal capital structure, which is developed by Robert Hamada from the Hamada equation. Done? Great. Okay, now I need the history here.